Good afternoon for anyone in the UK, and good evening or good morning for other parts of the world. So this is our third session of the day for the GSE Security virtual conference, and our speakers are Mark Nelson and Lenny Bradshaw, and they are going to be doing a session on encrypting the RACF database, a demonstration and some considerations. Throughout the session, please put questions in the chat, and I'll field them to our speakers. And then hopefully, if we've got time, we'll open up we'll unmute the audience for some questions at the end. Without further ado, over to you, Mark.
Thank you very much. Good morning, good afternoon, good evening. Mark Nelson. I'm here in Poughkeepsie, New York. Early morning, absolutely spectacularly beautiful here today. What we're going to be talking about is migrating your RACF database to vSAM and then to encrypted vSAM. It's an interesting topic. It's a fun topic. There are a lot of details. As I said earlier, if you got questions, put them in the chat. Somebody will interrupt us. What really excites me about this session is I get to tell you what I think it should do. And then our good friend Lenny gets to tell you how it actually works. If I do the math correctly, I think, Lenny, between you and I, we have about 90 years of experience on this platform and a whole bunch of those years in RACF. So please do take advantage of that. Ask questions, and let's get ourselves started. Lenny, would you introduce yourself?
Oh, hi, everyone. I'm Lenny. I've been knocking around the GSE world for many years, and I've been working with RACF for, well, longer than that, probably about, I'm just thinking about it, it's about over 40 years anyway. I think that's long enough. Back to you, Mark.
It is not long enough. We need experience like that. It's a fun ride. I love the product. I love the people. I love the mission. I think all of us who get to work on this platform are lucky. So the structure of this section is fairly straightforward. I'm going to give you the developer's perspective on how we think it should work. And then the real value, the meat of this session, is Lenny showing you how to go through some of these steps and giving some of the practical considerations. So let's get ourselves started. The path to RACF database encryption. So since its inception in 1976 is when it made generally available, it was used internally inside IBM for a number of years prior to that. RACF has been its own access method. That is, we do EXCPVR, we read and write cylinder head record kind of I/O, and we take the burden of all of that management unto ourselves. Well, a few years ago, we realized it was time to encrypt the RACF database. And we had a fork in the road, a choice we could make. Do we do that encryption ourselves, or do we look to what was announced as part of the pervasive encryption umbrella, the ability to encrypt RACF, to encrypt data sets of various types, including vSAM data sets? And we decided rather than trying to do it ourselves, we were going to go out and leverage the existing access method encryption that's now been around for 5 or 6 years. But what that meant is we had to move ourselves from the EXCP being our own access method into using one of the standard access methods. And that's what we did in ZOS v2r5. First thing I'm going to point out is this is an option. You do not have to move to a vSAM dataset or an encrypted vSAM dataset for your RACF database. It's a choice that you can make. Regulatory reasons may push you down that path, but there's no technology that's requiring you to do that. Everything we do in vSAM is also supported for non-vSAM as well. So that's important consideration. This is really a technical choice, a security choice that you get to make after having done the evaluations of the risks and threat mediations that you'll be able to do. Now, when we decided to move on to a vSAM base, right, we made some technical choices. And the first thing was we wanted to treat the vSAM dataset just the same way we did a non-vSAM data set in the sense that it was a container for RACF information, right? So we were not going to leverage some of the advanced vSAM things like retrieving a record by a key. We always want to retrieve it by its record number because record number ties right back to the relative byte address, which is how RACF was managing its own internal access to the RACF data set. So the mechanism that we implemented using VSAM has consistency with the RACF database access mechanisms. We literally just have to convert from that RBA, instead of into a cylinder head and record, we now convert it into a relative record number. Right. The next thing that is an outgrowth of that is we are not changing any of the RACF serialization mechanisms. So if you look in the systems programmer's guide, there's a list of NQs that we can issue. We will issue all of those, and we'll talk about another VSAM one that gets issued on top of that in a few moments. But once you're using VSAM, you have the ability to use VSAM diagnostics, any of the VSAM skills that you happen to have in your environment to do whatever maintenance you need to do on that VSAM data set. Plus, as VSAM introduces new performance characteristics, new improvements, we'll be able to leverage those. For a lot of reasons, VSAM made sense. Encryption was the first reason, but there are a lot of other reasons that just made it the right choice. So we delivered the ability to use a VSAM dataset in the base of ZOS v2r5. But there were a whole bunch of restrictions with that. You couldn't have a shared database, couldn't have a split database. The RACF database dataset could not be VSAM managed, SMS managed. You couldn't run in sysplex communications mode or in data sharing mode. Couldn't encrypt the data set, and you couldn't use the data set in master JCL. Nobody should be doing that, and that's still a restriction. But a little bit after ZOS 2.5 came to the marketplace, about 8 or 9 months later, we introduced an APAR. It's APAR 62267. So this is 2 years old almost, right? So I'm fairly certain most of you have it, but do make sure that you have this APAR and its prereqs. Those prereqs are very, very important. We'll talk about that in a few moments. But with that, we removed almost all of these restrictions, right? You can share it, can be in sysplex communications, data sharing mode, all the things listed there. The only thing we didn't remove was the, you can't use a VSAM data set out of master JCL. That's a horrible way to do things. I don't think that's a loss for anybody. We still come across 1 or 2 folks who are doing that. So we had a statement of direction for that, by the way, and then we delivered that with that APAR. So with that APAR 62267, there are 3 other APARs that go with it that are prereqs, 1 for VSAM, 1 for Media Manager, and 1 for BCF. What BCF is, it's the ICF set of functions that are available before ICF has been started. Now, we are using ICSF services. However, ICSF does not have to be started. We're using that BCF component, which allows the access of ICSF services, certain ICF services, but you have to start ICSF in a very specific way. You have to start ICSF out of ParmLive, and you have to specify the CKDSN keyword in your ParmLive setup for ICSF. That points to the CKDS name. So we need to be able to find the CKDS so RACF can find the keys that are used for the encryption of that VSAM dataset, which is the RACF dataset. So that's the reason for the restriction. Couple of considerations for this. Number one, you have to be converting reserves into global NQs. Specifically, the RACF, SysZ RACF NQs must be, reserves must be converted into global NQs. The second one, all the systems that share the RACF data sets must be defined in the same GRS complex, and no other RACF systems can be defined in there. Right, so those are restrictions to make sure that our serialization will continue to work, as well as this additional VSAM one, which we'll talk about in a moment. And the members of the sysplex must match exactly the set of RACF system sharing that are sharing the RACF database. That is the scope of the sysplex, has to be the scope of the shared RACF data set. And all of them have to have the same RACF sysplex communication setting. Right, so those are the restrictions. A lot of them are there because of testing things. We knew the environment, and we did extensive testing in that. And we just want to make sure that if you have other environments, let us know so we can figure out how to test them and make sure they'll work properly for you. From a programming viewpoint, VSAM versus non-VSAM as your RACF data set, pretty much nothing changes. No matter how you get information out of RACF, whether it's RACF commands, the rack route macros, any of them, request equals, whatever it might be, the Achinti IRX-util, any of those, the callable services, nothing changes there. Nothing changes to the set of NQs that RACF will issue, right? However, there's an additional sysd vsam NQ that's a conglomeration of the catalog name and the dataset name. That's actually pretty cool and pretty useful because as folks who have been on RACF, in RACF, and worked with RACF for a number of years know, RACF doesn't have a sysdsn NQ, a classic dataset name NQ, which means if you have your RACF dataset actively in use, right, there is no sysdsn NQ, somebody could delete it or somebody could migrate it to another volume. And when that happens, hilarity ensues. Right, it's not a good thing. The sysvsam NQ will prevent that now. That's neat. This warning here that applications which read the RACF database directly may have to take some actions. I have not run into any vendor application that's had this issue in the year and 9 months that this has been out. So we disclose it to vendors. Not an issue in my mind. But just in case you have some old product or your own custom written code, you may have to take a look at that. Custom written code that's not using RACRADICINTI, the callable services, IRX-util, or RACF commands, things that are reading the RACF dataset directly. So how do you create a RACF vsam dataset? Just like you would create any other dataset. So here we have the defined cluster. I'm using the example of creating a backup RACF dataset. So we're going to name it racf.back.vsam. It's a linear dataset, non-spanned. Erase simply says when this data set is deleted, vsam should erase it. Seemed like a reasonable option. Reuse has to deal with how vsam allows the resetting or rewriting of particular RBAs, so you do have to have reuse specified. Share options 3.3, that's the magic that says, hey, vsam, whoever is opening this data set is responsible for the serialization of the data set, responsible for the serialization of reads and updates. Right, so all of that is information about the cluster. Now for the data set itself, we're going to give it the explicit name racf.back.data. Right, so whenever you have a vsam linear data set, you have a cluster name, and then you have the actual data set name that is the data associated with that cluster. Normally it defaults to the cluster name .data, and we're choosing to choose a slightly different default, and we'll explain why when we go through one of the examples in a few moments. The control interval size, 4096, no surprises there. That's the size of the logical record length in a RACF dataset in non-vsam mode. The size of the data set, you express it in the usual ways, right? The one that we'll be copying from happens to be 8 cylinders, so this is going to be 8 cylinders. It makes sense. We do recommend that it only be allocated as primary, not primary and a secondary allocation. In a classic non-vsam RACF data set, having secondaries is catastrophically bad. That's not true for vsam, but we didn't do a lot of testing with secondary extents. I'll confess, I ran with secondary extents accidentally for a while, and I saw no problems, but allocated is all primary. That's what we're encouraging. It's a good thing to do. And free space is actually irrelevant for the RACF database because its contents are fixed at the time, or the size of it is fixed at the time that you min00 it or copy an existing data set into it. So free space of 0 makes sense here. All right. The process of migrating to a vsam dataset, and the migrating to a vsam dataset is regardless of whether it's encrypted or non-encrypted. So it's a big move, right? And we recognize that there's some risk associated with this. So what we recommend is that you consider migrating. I'm assuming everybody has a primary and a backup RACF dataset. Migrate the backup one first. Convert that one to vsam, then run with that for some period of time. Then do the rvary switch to make that backup now your primary, and your primary will now be your backup. You have to activate it as well, but we'll talk about that in a moment. Right, then run with that for a while. So you got a vsam primary and non-vsam backup, and then when you're comfortable, migrate the backup over to vsam. And as I said, this is regardless to whether it's encrypted or non-encrypted. The process to do the migration is the same. The only difference is when you define that data set, do you put a key label on it, right? So we're going to talk in terms of moving to vsam, but the only difference to moving encrypted vsam is putting a label on it, a key label on it represents the encryption key. And that, I don't want to trivialize that. There's a lot of setup that you have to do to make that magic happen with ICSF and disaster recovery, but we'll get to that. And Lenny has some good insights into that. Now, when you're moving to the RACF VSAM dataset, you can do it one of two ways. The first one is with an IPL. That was fairly straightforward. What you do is you allocate your VSAM dataset, you prepare a new RACF dataset names table or IRPRM XX member, which points to the new dataset. Then you use UT200 or UT400 to copy into this VSAM dataset, and now you IPL with this, the new dataset. But that's somewhat disruptive because there's a point in time where you're actually doing the IPL. And, oh, by the way, you have to do it for all of the systems sharing your RACF dataset at the same time. So this works great for smaller environments, test environments, but in the real production environment might not be the path you want to take. Now, if you want to go without an IPL, which is the way a lot of folks, I think, will consider doing this, you create that VSAM data set that is your new RACF data set, and we'll do this for the backup. You inactivate the current backup, so you do want to do this at a time of quiescence when there's not a lot of update activity going on, because those updates will not go to the inactive RACF data set. Then you copy the primary RACF dataset to that VSAM dataset using IRR UT200 with a new parameter called rename activate. Rename activate. And rename activate takes a dataset name as part of its parameter. And this is what we're going to spend a fair amount of time discussing. Now, rename activate, what that does, it's on UT200. Remember how UT200 works? It copies from a primary RACF data, so it copies one RACF data set to another data set. And the place where it's used the most is you take your live RACF data set represented by sysRACF, right? And you copy it into a data set that's referenced by the DD name sysUT1, right? That's how UT200 has worked for years and years and years. We introduced a value a few years ago, an option in it called parm equals activate. Parm equals activate said, do the copy from the active primary into the inactive backup and then activate the backup. We did that in ZOS 110, I think it was a long time ago. Now we're creating a new version of that parm equals activate called parm equals rename activate. And what that does is, first thing it does is it takes the inactive backup, which it finds from the dataset names table, and it renames it to the value that you specify on the parm equals rename activate. So the first thing it does is it renames your inactive backup RACF dataset, right? Then it renames the sysUT1 dataset, the target of your copy, and it renames it to that prior name, the one we had there just a moment ago. Then we do the copy from the primary to the backup, and then it activates the backup dataset. Now, there's a lot of things, a lot of processing in what I just described. We're going to take you through the details in just a moment. I will point out that rename activate can be used with both VSAM and non-VSAM datasets. That for folks who've ever had to consider doing the RVary dance, and if you don't know what that is, you can look on RACFL, a lot of discussion about it. This might assist. But let's talk a little bit more about this utility. I'll highlight once again, UT200 used to involve two data sets, an input and output, a classic copy operation. Now it involves three if you're using rename activate. It involves the live primary RACF data set, sysRACF, the inactive backup data set, and it finds that by looking in the DSNT, the current active DSNT or parmlib, and then it also involves the target of that copy operation. Right. And again, it renames the current inactive backup to that dataset name specified on rename activate. We sometimes call that the archived RACF dataset name. Renames the sysUT1 dataset to the RACF dataset backup dataset name, which it got out of the range table. Then it copies the primary into that RACF backup dataset name. Then it RVary actives the dataset. Couple of requirements on this. If you are using rename activate, right, you need to make sure that your primary RACF dataset, your inactive backup RACF dataset, and the dataset name that is going to be your archive RACF dataset name, the one you specify in rename activate open paren DSN, all of them must be covered by a generic profile. I know the people who absolutely love discrete profiles for everything, if there are any, will be disappointed by this, but part of the reason is we're doing all of these renames. And when you rename a discrete profile, there's some additional processing that has to happen, and it just didn't make sense. Have a generic profile copy protecting these. If something happens during that copy process after the rename, UT200 will attempt to rename things back to where they were, so you'll end up in the same starting position. All right, here are the
Sorry,
pictures.
Mark, 20-minute time check.
Okay, thank you. Do we have any questions out there?
No questions so far.
Excellent. We're gonna make it. Thank you for the reminder. All right. So here's where you start. You got a RACF dataset names table or parmlib entry pointing to RACF prim and RACF back. Both of those are NV, non-VSAM. That's all that means. And there's your blue RACF primary and the active backup in black, arbitrarily chosen colors. So the first thing you do is you create that VSAM dataset. So we created in that example racf.back.vsam. That's the cluster name, and the data component name is racf.back.data. I said we specified that name, and we're going a little bit against the normal VSAM convention. And the reason is that when we do the rename, we want to have that relationship correct. We want to have racf.back.vsam and racf.back.data representing the RACF data set. So it's just to maintain consistency. You don't have to have it. We just like doing it. All right, so you have the VSAM data set defined. Nothing has changed at this point. Now you are very inact the backup. You have to do that manually. That is not done by UT200. So now you've got an active primary and inactive backup, and this empty VSAM container data set floating off on the side. Next thing we do is the first rename. This is the one where we take UT200 takes the inactive backup and it renames to whatever was specified on the UT200 rename activate statement. So we said rename activate open paren racf.back.old, and what happens is racf.back becomes racf.back.old. First rename. The second rename is where we take that VSAM data set and we rename it to the inactive RACF backup data set name, which is racf.back. We get that from the data set names table or from parmlib. So here we have racf.back and racf.back.data. The VSAM naming convention is maintained, right? But it's still inactive, right? But it is there. The next thing that happens is UT200, just as it has since the beginning of time, copies that input data set into the output data set. In this case, sysRACF is the primary. Right? And we're copying it into that renamed data set racf.back. Right? It's a VSAM data set. Copy is done using IDCAM's repro. The last thing that happens is we do under the covers, a activate of that backup data set. So now at the end of this, you've got a primary data set, non-VSAM, a backup data set that is in VSAM, and a copy of, or actually the inactive backup off on the side. We've renamed that to racf.back.old. So you run this way for some amount of time until you're confident. Then you do the rvary switch to make the active backup your primary and the active primary your backup. Remember, when you do the rvary switch, the backup is made inactive. You do have to remember to reactivate it. And as one of my colleagues said, remember to update the range table or IRR, the RACF dataset names table, I should say, or IRR PRM XX to make sure that your system initialization matches the reality of how you're running. Then you run this way for however long it takes for you to become confident with this, and then you run through the process again using the backup data set that you had that you have been running with. And when you finish that, the process, you'll have an active RACF VSAM environment. Again, no statements in here about doing encryption because this process is independent of the data set being encrypted. Right. So if you choose to go VSAM and choose to go non-encrypted VSAM, then you'll be doing the process again at a later time to move yourself to encrypted, but that may be appropriate for some folks who are a little on the risk averse side. So a couple of minor things. We changed the manager and the storage requirements of the manager got slightly larger. So if you have region equals coded on some JCL for the RACF utilities, you should probably just make it region equals 0K or 0M. right? To make sure you don't have any 878 style admins. I talked about that additional NQ that's being done. That does mean that your VSAT, any utilities which reference the RACF dataset directly, should DISP will share it. Otherwise, they will simply wait for the ability to have exclusive access to the RACF datasets, which won't happen until you basically disable RACF. Oh, and before you think about going to encryption, you have to have ICSF properly set up. You have to have a defined, functional, and tested disaster recovery plan, because the last thing you want to do is encrypt the RACF database, move into your DR environment, and find out that you can't do the recovery that you would expect it to do. And the one rule, if you remember, nothing other than this one rule from doing the encryption of the RACF dataset: don't let the RACF dataset be the first dataset that you encrypt, right? Do something else first, get comfortable with it, get the system set up, and then you'll be good. So that's the overview. If there are any quick questions, we'll address them. But instead, and if not, let's move on to the exciting part, which is how does this work in the real world? So Lenny?
Yeah, no questions yet, Lenny or Mark. So yeah, please proceed.
Good.
Hello, everybody. Can you hear me? Mark, I'm going to have to grab hold of the screen, okay?
No, you can't have it.
Ah,
yours.
sorry. Let me have
It's
the
all yours.
screen. Gotta remember how to do it. Share my screen. There we go. Share. Right, you should see something there. Okay, I'm going to put up the same thing that Mark had, but I'm going to make it a bit smaller. I've got to make it a little smaller because I'm going to bring some other stuff up. So let me first tell you that I think I can use that thing. Can I know that one gives me the whole thing. There's another one of these that allows me. There we go. Right. So that's our presentation. And what I'm going to do is I'm going to start with a system. I'm going to IPL that system. I'm going to show that it's running a standard RACF environment with a non-VSAM dataset. Then we're going to define a VSAM encrypted system. We're going to migrate into it. So first thing I'm going to do is start up my system. I've got to sign in. This is running. I'm just going to let this go while I just talk about it afterwards, okay? Because it needs to run. So this is now starting up the microcode for the ZPDT. ZPDT is running actually on this PC, which is sitting below my desk. I'm running on this PC. This thing is running Ubuntu Linux, and it has a ZPDT key, which is plugged in the back of there. What I need to do now is start up a console. So we have a console. I'm going to minimize that slightly. Then I'm going to tell this thing to IPL. And then I'm going to forget about that screen there. And those people who know and are familiar with ZOS IPLing will see this and recognize this. And it IPLs just as if it's a normal system and will be up in just a moment. I'm going to go back to here and explain that when we come up on this system, this is the version of PalmLib that we're going to be using. And as Mark mentioned, you have to start ICSF from IASys. It must be started early. The name of the proc that you use, in my case, is CSF, and the palms that I pass to it are 00. When you go to create your ICSF procedure, you'll find that the sample that IBM provide doesn't use this palm parameter. So you'll have to make some JCL changes to do that. It's not very difficult, but I couldn't find it documented anywhere. It may be that it is documented somewhere. Let's have a look at the console. Oh, look, looks like it's IPLing nicely. be coming along soon. We'll soon be able to sign on to TSO. The ICSF system we have is configured with 3 key stores. We're only going to be using one, the CKDS, and the CKDS is actually stored, or it's catalogued in a user catalog called user catalog.users. I don't have them catalogued in the master catalog. I think we're probably all up now, so I should be able to bring that one down, bring another one up, and voila, I now have a system that I can sign on to. Voila. Okay, I'll park that to one side for a moment and we'll go back to the presentation. And I'll just talk a little bit more about what's going on here. Do feel free to interrupt me and ask questions or say, what on earth are you doing, or whatever you choose. Right. RACF on this system is currently configured with sys1 RACF DS and sys1 RACF DS.backup. These names are the names that are supplied by IBM when you get an AD/CD system. And you'll see as well that I've got them catalogued and existing on the same volume. And this is something, of course, that you shouldn't do and shouldn't be done. I don't worry too much about it because I know that all my system is actually running on the same 2 terabyte solid state device that's running inside that PC that's under my desk. But in general, it's not a good idea. Don't do it. I'm going to talk a little bit more about that at the end. Z-Secure is running on this system. It's Z-Secure 3.1, and I have it actually running now in network mode. So the CKN server is running. When I did this presentation last November, I didn't have it running, but it is running now. And you will see that Z-Secure works with the encrypted RACF database in a very transparent manner. In fact, in an entirely transparent manner. As Mark mentioned, the VSAM dataset is to be encrypted. In order for a VSAM dataset to be encrypted, it must be SMS managed. Further, it must be in extended format. Extended format is a type of format of datasets which was introduced probably more than 25 years ago, but a lot of people still don't use it. With extended format, you have extra blocks or extra data that is appended to each physical block that is hidden from the access methods. It's one of those things that is far better for encrypted datasets. When datasets are encrypted, they use a chained mechanism, and knowing exactly where physical blocks are, not having to count them, means that extended format is far better for it. When we create the dataset, we have to specify key value, and that key must exist in the CKDS. And I highly recommend that you protect the key in the CSF keys class. Also, I recommend that you have the CSF keys configured for granular control. If you don't know what granular control is, talk to your ICSF people. Or I can just tell you very quickly that when CSF keys was first introduced, the only level of control you had over a key was read. And with read access, you can create the key, destroy the key, use the key, change the key, do anything to the key. And it was felt some while ago that that was perhaps not the best approach. And you can put a granular level of control in by defining this resource here. And that means that you then need different levels of access to do different things with a key. This system is known as S0W1. It has volumes sysuse and sysSMS. And you'll see that sysuse was where the RACF database was. And we are going to create the new RACF database on sysSMS. If you lose your RACF database, if you encrypt your RACF database and lose your encryption key, you've lost your RACF database. The data is effectively cryptographically deleted. So you should have key management in place. Mark said as his last point, and a very important point, don't make this the first thing you encrypt. So you should have some experience of encrypting data sets, and I would expect you to have key management in place. In the past, for key management, I've used EKMF Web. I think that is now called the Unified Key Orchestrator. And I think that URL there is correct. An alternative is to use DKMS, which is a much more sophisticated product from Copenhagen. And probably you want a TKE, which provides you protection and fast maintenance of master keys for your ICSF system as well. Okay, so I'm going to go into the demo now. At the end of that this process, we'll have a cluster name that is the same as the old VSAM, non-VSAM database. And that removes for me the need to have a new IRR Palm member. I can use the same one, carry on. The new VSAM clusters I'm going to define are going to have .new on them. The data component of each database name is not actually critically important. And Mark went through quite a lot showing how you can manipulate those names at the point when you define the cluster such that you end up with them in the right name. I'm going to use a slightly different technique just to confuse things, but you'll see that I rename those data components along the way. All the jobs I need to do this are in a single PDSE, and they are named in alphabetical order, as you'll see. If there's anything missed, you need to read the instructions. There is absolutely no substitute for reading those instructions. Things are going to be different in a sysplex. This is not a sysplex. So always read those instructions. I'm going to create it. I'm going to allocate it. Sorry, you're going to create the encryption key. Actually, I'm not going to create the encryption key. It's already created, but I'm going to show it to you. We're going to allocate the new database, create a backup, create a member so that we can use our backup should we ever need it. We're going to go through that new dance with palm equals rename activate. And at the end, we're going to run a DFSMS DSS print of the old data set and also of the new data set to show that they are entirely different. Okay, at this point, I'm going to minimize this, and we're going to go into the demo. So this is where I'm really driving. This is the data set that we started with. So as I said, I have these members in alphabetical order because that makes life easy for me. I know what I'm doing, or I'm supposed to know what I'm doing anyway. Right, so I have some notes in here on the names that I'm going to be using. So the primary is sys1 racfds.new, and it'll be new.data, and the backup will be backup.new and backup.new.data. That's what they'll be allocated. They'll be allocated on the volume sysSMS. They're going to use that encryption key, which will be protected, and so on. There's a data class of this, which is a data class that was supplied with this system, and that is adequate for me to create extended format data sets. The storage class has the guaranteed space attribute on it. I'm not entirely sure if that's mandatory, but we're using it anyway. And my IPL palms are held in that data set there, and it's the IRR Palm 00. Okay, so the first job is going to define things. So it's going to define the encryption key. It's going to give permission to the encryption key for me, and it's also going to give permission to the encryption key for sys1. That's for those users who are going to access the RACF database directly, possibly using ZSecure, and for CKN, which is for the ZSecure server. So I'm going to run that job, and it ran to completion. It's up there. And sure enough, it was already defined, but okay, we're all good. Any queries on this? Please stop me. The next step says define a new key. So to do this, I'm going to go to ICSF panels 557. So 5 is utility, 5 is CKDS, and 7 defines the new key. Now, in my instance, I'm not going to define it because, as I said to you before, it is defined already. So I'm going to put a 1 in there and show you that there is, in fact, I have the massive sum of 4 keys here for encrypting data sets, and racf.master.encryption key is down the bottom here. I can examine that key with the K command, and you can see various information. You can see I created it quite a while ago, 2 years ago, in fact. Well, nearly 2 years ago. You can see the service that last used it, which was the key record read. You can see it's an AES 256-bit key. There's various key check values and so on. I'm going to come out of that now, and you're going to trust me that key's there, and I'm going to allocate the data sets. Now, as I said, the names for the data components in my instance, I'm going to let default to cluster name.data, and we'll be modifying them afterwards. In setting this up, I've used this wonderful new capability in JCL, which I hope you're all familiar with, that together with this symbols equals JCL only, I can use to pass parameters from the job control into in-stream data. So you can see here, I'm creating this as 20 cylinders and so on and so on, everything. So the volume prime, I've got sys SMS, and the backup volume is also sys SMS. And as I've said to you, don't do that. I'm just doing it because it's convenient for this demo. So I'm going to submit that job. And it's run before I can blink. And I've got a conditional delete in the front. And then you will see that it has been created, and it says it uses that encryption key. And the status is 0, and everything's fine. Wonderful. The next thing I'm going to do is I'm going to take a backup. And all I'm doing here is I'm taking a backup of the existing data sets, and I'm going to create them as sys2. Anybody wants this job control after I've finished, let me know. We can supply it. Backups run. Anyone who wants to see that? The interesting thing is that the IR UT200 is now using eCam Threat Pro. Voila. It also says here, set up a Palm nib for the, and this is for my backup that I've just created. So I've set a sys21, previously it was sys1, so I've got it as a backup. Of course, if you're using range table, or you're using multiple primary and backup data sets, then you'll need to do the equivalent changes. In my instance, all I'm doing is I'm using a single RACF database, and it makes life much simpler. But there are obviously very good reasons for using a split database. Now, after that, the first thing I'm going to do is I'm going to inactivate the backup. You will see something here that doesn't usually happen, and that is the job ran to completion without me doing anything. That's simply because that message was issued there, and I have a rule in my auto rule that simply replies to those R-varies, which again is something you should definitely not do, but it makes it easier for this demo. So after this, you'll see that I have an inactive and deallocated RACF backup. Now I'm going to do the main part of the dance. This is the part that Mark spent so long explaining. And the fact that we're doing it with an encrypted database makes not a whit of difference. That's all handled by vSAM. RACF doesn't need to be involved. So I'm locking the primary. I'm copying the primary to the new backup and renaming it. And renaming the old one, renaming the new one. Then I'm unlocking the new primary and backup. No doubt this one will take a moment longer, but it runs pretty fast. So we'll look through this lot. Lock function requested. Rename successful, rename successful. And now I have the primary on sysuse, which is the old non-vSAM data set, and the backup on sysms, which is the new vSAM data set. The reason I got a return code 4 is because sysin statement has been ignored, activation has been specified. There's no sysin in this IRR UT200. I don't think there's much point in looking at these options, but repro again. Okay, going back to my data set. Next thing I'm going to do is I'm going to alter that data component. If I what's this one.racfds here, just doing a little bit of ad-libbing, you'll see that we've got looks like a slight mix of things there, which is not quite what you want. So we do this alter, and this is an alternative to the way that Mark put in his presentation, which is a good method as well. I don't think there's a wrong method here. The important thing is you get the right answer at the end of it. That's a simple alter, and voila, worked. Sorry. So now we're going to switch. We're going to switch to primary and backup positions. Again, you will see here that I have something that replies to that, and it's done it. Okay, so I won't bother going through the output from that. And here we have a very similar job to the one we did before that does the 2 renames and does the locking and unlocking of the database along the way, and does the copy in the middle. So of course, I'm not doing the very thing that Mark said you should do, which is to run for a while with the backup encrypted and the primary unencrypted to get yourself a nice warm feeling. I don't have that problem. I hope I have a warm feeling already. And again, a return code 4 for the empty sysin. But again, this all works. It's really nice when you get a new IBM capability and you go to use it and it all works. It's wonderful. And then we switch. Okay. I'm going to look at the output of that. Then we've got another alter for that data component. And as I said, if you use the naming conventions that Mark gave you, you can avoid this step. That is a very simple alter. I'm sure I'm going far too fast for some people. And finally, I'm going to reactivate the backup. And of course, as expected, there's an auto reply and it's done. And at that point now, if I go to option 6 and I do an rvery list, oh, well, if I spelt rvery right, it'd be right, wouldn't it? And you can see now I'm up on these same dataset names, but they're now on volume sys SMS. If I go to 3.4 and look on sys SMS, you'll see, oh, maybe if I put sys1 on there to avoid the confusion, we'll see we've got our RACF database there. Now, let's do something a little different. Let's go to Z-Secure. For those of you that know Z-Secure, other products are available. Okay, I'm going to go into Z-Secure to show the setup, and I'm going to unselect that on account of that system's not active. I'm going to edit this one to show you what I've got. This is actually coming from production system prod. It's seeing CKN serve system. But if I wanted to look at some data sets, for example, well, let's just put in sys1. And well, everything's looking fine. I can look at these things just the same as I could before. Everything looks just the same. But this is a vSAM dataset we're reading. So what I'm going to do now is run a print. Now, when you run a print of a data set using DSS, it doesn't go through the access method. Consequently, it doesn't decrypt the data. So a DSS print prints the physical blocks that's on the disk. The unfortunate thing about the print command is that I can't stop it after 10 records or something like that. So I have to print it all. So if I submit this, this is going to print the old prime and it's going to print the prime. But when it prints the prime, it has to print the data component. So I have to put .data on here, whereas up there I don't. And this takes a little while, unfortunately, because it's going to write a lot of data. What you'll see as well is that not only does it write a lot of data, but for the encrypted data set, it writes a lot more data. And we'll see why that is in a minute. Do I see a question in the chat?
Yes, just had a comment from Mark, Lenny. So,
Yeah.
Lenny, can't you limit IDCAM's print using something like print in file in DD, dump skip? Yeah, I don't need to read it all out. It's in the chat.
Yes, I guess you could do. Yes, yes, I'd have to do that beforehand. Yes, could be done. Have I ended yet? No. Well, I'm going to go into this anyway and show that printing the old RACF database, people should see things that they recognize here. If anybody's ever browsed the RACF database, you'll know that the templates come near the header. So you'll see all those here. So this is the old non-VSAM data set we're looking at, and you can go through and see all sorts of structure, which I won't bother identifying. If, however, I look at the new one, sorry, not a question mark, but a select, this doesn't really look like anything at all. And as I come down here, you can see there is nothing here which means anything on the face of it to anybody. This is just encrypted data. The reason why it writes so much more data. Hello? Oh, I had a jump there. So apologies. The reason why it writes so much more data is because when it does the old one, if I scroll down here, wherever it finds blank records, it says that to that is the same as the one above, because all the binary zeros, there's a whole lot of them between BE0 to BFF. So it eliminates a whole lot of data. However, when you encrypt the data, you don't get that. There's no consecutive lines of binary zeros. Just doesn't happen. So it prints everything, and hence the output is a great deal more. Right. I'm not going to go any further with what I'm doing there. My next step after that is to undo, and it's the instructions to me to show me how to reinstate my system with a non-VSAM RACF database. So I'm going to move back to the presentation, and at this point, I think I will go full screen. Okay, we did the description of working environment. We've done all that. We did the demo. We did the dance. Okay, and now I have some considerations that I want to raise about single points of failure and the nature of encrypted RACF databases. So it struck me that, and it's been a concern of mine for a long time, that if people have a sysplex and they have one master catalog for the entire sysplex, then that becomes a single point of failure. I've tried to raise this with IBM at various times. Some people are interested, some people aren't. It's a single point of failure. If you the loss of the master catalog will lose you your entire sysplex. If you've got a duplex RACF database, then obviously that's better. If you've got a single LPAR, then that's what you've got. But if you've got two LPARs, then loss of this master catalog will cause but loss of both of your LPARs. And with multiple, you get multiple. So the way to resolve those problems with RACF in a Sysplex is to have 2 master catalogs. But the problem is, of course, that your RACF databases now need to be cataloged in both master catalogs. I don't know if anybody's starting to see where I'm going with this, with vSAM RACF databases, but you should see soon. An alternative is that you have one master catalog for one of your systems. Perhaps you've got a networked concentration system. You have one master catalog on that and another one on for all the others. Then the need for recataloguing things becomes less critical, because most of your work is going on over here. vSAM datasets, however, are owned by a catalog. So while a non-vSAM dataset uses a catalog to point to it, a vSAM dataset holds a whole lot of other information in there. And that other information must be maintained as the vSAM object is changed. So you change things on the vSAM object. Some of that is recorded in the VVDS on the volume in question, and some of it is reflected back to what's known as the BCS entry, the catalog entry in the catalog. Now, because the data set is owned by only one catalog, it can only reflect that information back to one catalog.
Lenny, we are at time. Do you have much more to cover?
I have another 5 minutes or so.
Okay.
Okay. So the issue here is if you're going to have a duplex dataset, duplex RACF dataset, you could have them cataloged like this in 2 master catalogs, but the problem is that the rename activate won't work because it only works back to one master catalog. So that rename activate mechanism is wonderful, but it has shortcomings. An alternative is to use another user catalog in between and have your vSAM two data sets in a single user catalog. But the problem is now you've moved the single point of failure from the master catalog to the user catalog. And so another method is to use 2 user catalogs, one for the primary and one for the backup. Use different high-level qualifiers for the primary and backup. Primary and backup RACF databases. When you have multiple RACF databases when RACF database in user catalogs, you can get these messages out. And IBM Catalog and Management has said you shouldn't do that because there are recoverability issues. The solution is you use a single user catalog for each RACF database, and you don't put anything else in that catalog. So we end up now with master catalogs, user catalogs here. And remember, you've also got now, because you've encrypted, you've now got a CKDS, and the CKDS could become a single point of failure. However, your CKDS is a rather different creature from your RACF database. It doesn't have to be online all the time. It can be switched in flight, and a lot of other things can be done with it. It is managed dynamically. It's dynamically allocated by the CSF started task, and as such, it can be reallocated and changed. So if you are moving to vSAM catalogs, if you're moving to a vSAM RACF database, consider these issues, because if you have multiple master catalogs, that rename activate mechanism will work for one of those master catalogs, and you need to modify your process to handle your other master catalogs. I know of sites that run 4 5-way sysplexes and use a master catalog for each LPAR. These are the people who are going to have to adjust their approach, shall we say. So in summary, RACF database is fairly straightforward. You must decide your desired endpoint in terms of how you're going to run. Do you want a single point failure? How are you going to address those issues? Get your SMS requirements organized in advance. Make sure you've got ICSF team on board. Always consult the manuals. And also, of course, build a test process on your sandpit and run through it a few times. And that's it. Okay,
Brilliant.
so apologies for overrunning.
It's okay. We've got a break in between this and the next session, so I will open it up to questions. So everybody can now unmute if they'd like to ask any questions to Lenny or Mark.
So Lenny, I posted a comment. That issue with the catalog, a user catalog and the RACF data set in it revolves around the fact that catalog recovery can't occur while the data set is open, and the RACF data sets are owned out of master, right? Your proposal of a single data set in a user catalog, I think, really mitigates that risk, because it means if you had to do a catalog recovery option, you might have to RVery enact the RACF data set, but that's it.
Yeah.
Okay. So we've got no one's unmuted to ask questions, and we've got nothing more in the chat. So just last thing to do is just thank you very much both for an absolutely fantastic presentation. And to the audience, please could you fill out feedback for both Lenny and Mark. So this is session 8D. With that, I'll close the call. Thank you very much all. Hopefully see you on the next session in 20 minutes.